Welcome to Chapter 10, Chemical Quantities. Section 10.1, the mole, a measurement of matter. Here's our objectives. Be able to describe methods of measuring the amount of something, define Avogadro's number as it relates to a mole, distinguish between the atomic mass of an element and its molar mass, and describe how the mass of a mole of a compound is calculated. Now, a lot of those things sound kind of confusing right now, but they're really not too bad. So we'll go through these, and hopefully by the end, this makes a lot of sense to you. All right, so you can measure things in a number of different ways. Usually we do it by one of three. Counting, finding the mass, or finding the volume. So if we count, we could count and use numbers like pair, which means 2, dozen, which means 12, or gross, which means 144, things like that. Those are examples of words that mean actual numbers. So you could say a dozen apples is equal to 12 apples. We know that, okay? Maybe we would know that 2 kilograms of apples is also equal to a dozen apples. Or maybe we would say a dozen apples is the same as 0.2 bushels of apples. So any of those could be examples of ways of counting apples. So let's take a look at this example. It says, what's the mass of 90 average-sized apples if 1 dozen of the apples has a mass of 2 kilograms? Now, you're going to notice that this is going to go back to what I used to do, what we talked about way back, I think Chapter 3. We talked about dimensional analysis, and then I call it factor label method. And you need to get used to doing that again, because we're going to do a lot of that as we do this. So the first thing that I always do is I always put down, what am I trying to find? So in this case, I'm trying to find, and I always put a question mark, trying to find the number of, or the mass. So I'm going to try to find the kilograms of apples, and I'm given 90 apples. So I start off with 90 apples, and I'm trying to figure out how those are going to be converted, how we're going to get that converted into kilograms. Well, what we know is we know that a dozen apples has a mass of 2 kilograms. So we can't go directly this way, but we can, and I didn't write this very small, so let's start this over here. Let's start this over a little bit. So if I say, hey, how many kilograms equals 90 apples? And then the first thing I'm going to do is convert from apples, which I know that 12 apples is 1 dozen. And I know that 1 dozen is 2 kilograms. And so I can cancel all of those. Those will cancel out, and I'm left with kilograms, which is what I'm trying to get to. And when I multiply that out, this equals 15. So 15 kilograms. So not too bad. Just a little bit of review on our factor label method and so on. So I want you right now, stop the video and do those 2 problems. So hit pause, do these 2 problems, and then come back. Okay, so it says if 0.2 bushels is 1 dozen apples, and a dozen apples has a mass of 2 kilograms, what's the mass of 0.5 bushels? So what we're trying to do is we're trying to find the mass of apples, so that's kilograms of apples, and we're given 0.5 bushels. And we know that 0.2 bushels is a dozen, so we can do that. We can convert that. So 1 dozen equals 2, or 0.2. Oops, let's cross it out. 0.2 bushels, and then we can convert from dozen to kilograms, because we know 1 dozen apples is 2 kilograms. And so let's check. Bushels cancel, dozens cancel. We're left with kilograms. That's what we're trying to find. And let's see, we've got 0.5 times 1 divided by 0.2 times 2. So 0.2 goes into 2 10 times that. So that would give me 5 kilograms. Don't mind the cats. They're just having a little fit. So looking at number 2, it says assume 2 kilograms of apples is a dozen and that each apple has 8 seeds. How many apple seeds are in 14 kilograms? So we want to know how many seeds. We are given 14 kilograms. And we need to convert that somehow to apples to figure out how many seeds we have. So we can go 14, or we can go change 2 kilograms to a dozen. So we know 2 kilograms is 1 dozen. And we know 1 dozen is 12 apples. And we know that 1 apple has 8 seeds. So we can cancel all that. And we get 14 divided by 2 times 12 times 8. And we get 672. What is a mole? Nope, that's not what I'm talking about. What we're talking about is a unit of measure. So just like we talked about a dozen or a gross or a pair, that's what we're talking about. It is a number, 6.02 times 10 to the 23rd. You should memorize that number. You will use it a lot for the rest of the year. So know that number. It is sometimes known as Avogadro's number, since he's the one who came up with the number. And there's something that you need to understand, the idea of a representative particle. A representative particle is the species present in a substance. Now that sounds kind of weird, but basically what we're talking about is we're either talking about atoms, if we're talking about individual atoms like iron and silver and stuff, or we're talking about molecules, like if we're talking about water or methane or something like that. Or we're talking about formula units if we're talking about things like sodium chloride and magnesium sulfate and so on. There are 7 elements that you need to be aware of, and that they do not exist as atoms in nature. These are the 7 elements, and you need to write them in big bold letters, put stars all around it, because they will cost you many, many points on tests if you do not remember that these 7 elements are diatomic. So remember what they are: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And if you look at a periodic table, you will notice that they are these 7 right here: nitrogen, oxygen, fluorine right down here, and then hydrogen, this guy right over here. Okay, so it's kind of the little 7 over here: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen, who always fits in the wrong spot. Okay, so make sure you know those. Very, very important. Write them down. Maybe they'll be on the quiz. That would be a good question. All right, we talked about formula units, and formula units are kind of the word that we use when we're talking about ionic compounds, because technically they are not molecules. There's no 2 specific or 3 specific atoms that go together. It is simply a ratio, So we're talking about, for ionic compounds, we simply call it formula units. But don't let that word hang you, get you hung up on things. If that confuses you, think of it as molecules, because we're talking about pretty much the same thing. We're talking about the unit that we're talking about. So if we were talking about NaCl, the formula unit is NaCl. If we're talking about MgCl2, that's the formula unit. Versus water, H2O. Now, there doesn't look to be much difference. The only difference is this is molecular, this is ionic. So we're not really talking about anything different. If we have a mole of any substance, if we have a mole of iron, if we have a mole of water, if we have a mole of salt, we have this many represented particles, whether those particles are atoms, molecules, or formula units. So if I have a mole of iron atoms, I would have 6.02 times 10 to the 23rd atoms. If I have a mole of water molecules, 6.02 times 10 to the 23rd water molecules. If I have a mole of salt, I have 6.02 times 10 to the 23rd formula units of sodium chloride. Take a look at problem on page 291. So turn to page 291, follow along. Or here it is, not a very good, I don't have, for some reason they don't have images of all of them, so I had to take a picture. But it says, magnesium is a light metal used in the manufacture of aircraft, automobile wheels, tools, and garden furniture. How many moles of magnesium is 1.25 atoms of magnesium? Now this is a very common problem that we're going to have, so get used to doing this. So what we're saying is we want to figure out how many moles of magnesium if we have 1.25 times 10 to the 25th, I think. I can't quite read my picture here. 10 to the 23rd, I guess, times 10 to the 23rd. Unfortunately, I didn't write small enough to fit this on here, but you can see what I'm going to do next is I'm now going to multiply by 1 mole of magnesium. For 1 mole, there's always 6.02 times 10 to the 23rd atoms. So I just multiply that out, and I come out with my answer of 0.2 moles. So, once again, stop the video. I want you to do problems 3 and 4. I want you to stop and actually do them. If you just watch me do them, you will not learn them as well. This is something you must know. What we're doing in this chapter, you will do for the rest of the year. You must know how to make conversions to moles and grams and so on. Got to do it. So stop the video and okay. So it says question 3. How many moles is 2.8 times 10 to the 24th atoms of silicon? So we want to know how many moles of silicon equal to 2.8 times 10 to the 24th atoms of silicon. Now remember, every represented particle has 6.02 times 10 to the 23rd of those particles. So if we're talking about moles of Si, 1 mole of Si, 6.02 times 10 to the 23rd atoms. And this is whatever we're talking about, atoms or molecules or formula units or whatever. So atoms will cancel. I'm left with moles, and if I take 2.8 times 10 to the 24th divided by 6.02 times 10 to the 23rd, I end up with 4.65 moles of Si. Hopefully that's what you got too. Number 4 says how many moles is 2.17 times 10 to the 23rd representative particles of bromine. So we want to know how many moles equals 2.17 times 10 to the 23rd representative particles of bromine. Bromine happens to be a molecule because it's one of those Br2s, it's one of those diatomics. So we'll just put that in. Now that's not really important as far as being able to figure out this problem, but we're going to call them molecules. I should have wrote in here, molecules. 1 mole Br2 is equal to 6.02 times 10 to the 23rd molecules of Br2. So molecules will cancel. I'm left with moles. That's what I'm trying to find. So now I just got to take 2.17 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and I end up with 0.360 moles.